Greetings to all. This is Mowlika, Department of Physics from St. Joseph's College of Arts and Science for Women, Hosur. In this video, I am going to explain about Davission and Germer experiment. In 1924, Louis D. Broglie postulated that all forms of matter have both wave and particle characteristics. According to this hypothesis, electrons, just like a light, have a dual particle wave nature. Physicists C.J. Davission and L.H. Germer were the first experimentally proved the nature of material particles in 1927. This image represents the experimental setup used by Davission and Germer. It consisted of nickel crystal, the target, an electron gun, and the detector. Electrons are produced by heating a filament by a low tension battery. The electrons are accelerated through a potential difference in the electron gun. This electron beam falls on a nickel crystal. The electrons are scattered in all directions by the atoms in the crystal. The detector can be moved to any angle related to the incident beam. Davisson and Germer plotted a graph taking the angle between incident and scattered direction of the electron beam degree along the y-axis and the intensity of the scattered beam at different values of accelerated potential along the x-axis. Until accelerating voltage in 40, the graph remains fairly smooth. There is no significant changes occurred. Then, when the accelerating voltage becomes 44 voltage, the bump appears on the curve. As the accelerating voltage is increased to 48 volt, the length of the bump increases. The bump becomes most prominent in the curve for 54 electron volt at 50 degree. As the accelerating voltage is further increased, the bump decreases in length and finally disappears at 68 voltage. De Broglie's wavelength lambda of the diffracted electrons using Bragg's law. We know that the Bragg's law is n lambda is equal to 2d sine theta. Here n is equal to 1. D spacing of the atomic planes which can be measured by X-ray diffraction is 0.091 nanometer. The angle of incidence is 65 degree. Finally, we got the wavelength of diffraction electrons using Bragg's law is 0.165 nanometer. The expected wavelength of the electrons using de Broglie's formula. The formula is lambda is equal to h by square root of 2mke, where h is the Planck's constant, value is 6.63 into 10 to the power minus 34 joules second. M is the mass of the electron, that is 9.1 into 10 to the power minus 31 kilogram. K is the kinetic energy, 54 electron volt. And E is the energy of the electron, that is 1.6 into 10 to the power minus 19 electron volt. By substitute the values in the formula, we got the wavelength of diffracted electron is 0.166 nanometer. The observed wavelength agrees well with the expected wavelength. The Davisson-Germer experiments thus directly verifies de Broglie's hypothesis of the wave nature of the moving bodies. Thank you.